Pete Starkey with iConnect 007 at Electronica in Munich, here at the booth of Electrolube. I'm delighted to meet with Alistair Little, and Alistair is Global Business Technical Director of Resins Division, or likes to be known as Mr. Resin.
That seems to be the title I have been christened within the company. Nice to meet you, Peter.
Alistair, it's wonderful to meet you. And I know it's a busy day for you, but thanks for sparing your time.
Yes, I just hope that people can hear us over the hubbub of the show.
Yeah. I think we share an interest in resins, but I think from your point of view, and knowing that Electrolube is the solutions company that enjoys rising to challenges, what are the current challenges that the automotive industry is looking to you to resolve?
Well, with the change from the traditional combustion engine towards more electric vehicles, there's now an increasing desire for materials which have higher temperature resistance. So we've recently launched a new product designed specifically to meet that high temperature requirement, and will now go up to 180 degrees centigrade continuous service temperature, and we'll also then do excursions of up to 30 minutes up to 215.
And whereabouts in the automotive assembly would these sorts of resins be used?
To be honest, anywhere where high temperatures may be encountered, such as around the electric motor itself, which can actually generate quite significant amounts of heat, but also were areas where, because of its superb chemical resistance, it can also withstand things like sulfuric acid, battery oil, engine oil, lubricants. So anywhere where such materials may come in contact, and you need to keep those more nasty materials away from the electrics. But then leading on from that, because of the likewise the desire for lower emissions, lighter weight and such like, the LEDs are becoming much more important within the automotive industry. And last year we launched a couple of resins specifically aimed for LED encapsulation, and this year we have reinforced that range with a couple more additions, which are designed for potting much larger units, and a much longer working time, to enable the customer to have a range of options in terms of hardness and also of potting capabilities.
From our experiences on the PCB side, we've seen lots of developments in thermally conductive substrates for LED assemblies, particularly for automotive applications. And certainly from my personal point of view, being a PCB man, you tend not to think beyond the thermal characteristics of the substrate itself.
Yeah.
Once the things assemble, you forget about the next stages, the additional things that need to be incorporated to improve the performance, improve the reliability of the assembly.
One of the big things that is a major killer for the lifetime of an LED is heat. And so most LED light assemblies have quite a large significant lump of metal on the back acting as a heat sink to take away the heat. We have a range of products, one of which we've launched, a couple of which we launched just this year. One is a thermal change, phase change material, and another one is actually a epoxy system which can be used at the back of the PCB to help bond the PCB to the heatsink to enable better thermal conductivity across, and to be able to maintain a good lifespan of the LED.
Alistair, so far as the LED device is concerned and protecting the device itself from the environment, what sort of materials would you use in that application?
We've gone down the route of saying, in order to protect the LED and to maintain a good UV stable material, because we do not want to have yellowing or very, very low yellowing levels, we use aliphatic polyurethanes, which have the advantage of a good working temperature range, that's normal environmental consideration. So they will go from -30 up to +80 degrees centigrade, which is what a normal externally mounted LED light will see. But also are sufficiently tough enough to withstand day-to-day knocks and scrapes. We have people who have looked at these resins for direct contact with basically shoe soles, and they have survived their testing regime admirably well.
Yeah.
And so you never know, one day you may actually be out walking out onto one of our resins.
Alistair, it's wonderful to talk to you, and I think it gives the industry an awful lot of confidence to know that the solutions company Electrolube has got scientific expertise behind these products. You don't just mix stuff up in buckets. You actually understand the chemistry of what you're putting together. It's I think very confidence-inspiring to know that there are people like you involved in the industry. Thanks very much indeed for talking to us.
Thank you very much for your time as well.
It's been a great pleasure.
Thank you.
Pete Starkey with iConnect 007 at Electronica. Thank you.